guys, welcome again once again to our YouTube channel. Welcome to AdMaths plus Maths. Okay, so we are going to solve problems regarding derivatives of trigonometric functions. But before you will be watching this one, make sure that you have watched already the derivatives of trigonometric functions and how did I prove out that the rules in derivatives of trigonometric functions, and how did I use the first principle in getting the value of the derivatives of trigonometric functions: sine x, cosine x, and tangent x. Okay, so if you want that video, please click the card on top. Let's move on to some examples. Remember, I said in the previous video that the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, the derivative of tangent x is secant squared x. Okay, so if we are trying to differentiate problems like A, B, and C over here, then we will just be using these three concepts of the derivative of sine x, cosine x, and tangent x. Example, letter A. Okay, y is equal to 4 sine x. So since 4 is just a numerical coefficient of sine x, then I will bring out that 4, then find out the derivative of sine x, which is cosine x. Basically, the derivative of y in terms of x here is 4 times cosine x. Okay, next, letter B. Y is equal to sine 4x. Okay, how about Mr. Mars if I have a problem with this one, that there is a value of, or there is a numerical coefficient on the angle. Okay, what you will do is you cover up that value, and remember that the derivative of sine is cosine, so you will just put in the cosine, and then get the numerical coefficient of the x, which is 4. That numerical coefficient will be moved. Okay, or if you want, you can differentiate that one, so that is 4. Then bring back whatever is the value of the angle, which is 4x. So the derivative of y in terms of x, if y is equal to sine 4x, is 4 times cosine 4x. Okay, next, how about letter C? For letter C, you will notice that I have two expressions. First expression is I have x, and the second expression is sine x. So there are two expressions. Thus, I'll be doing product rule. Why product rule? Because I basically multiply x and sine x. Okay, so u is equal to x, v is equal to sine x. What is the derivative of u? It is 1. What is the derivative of sine x? It is cosine x. Remember, product rule says v du plus u dv. Okay, so you just plug in, you will have sine x times 1 plus x times cosine x. So basically, the answer here is sine x plus x cosine x for letter C. Next, let's move on to some more examples. You will notice that I have 7 cosine x. What is the derivative of cosine x? It is negative sine x. So it will just become negative 7 sine x. Okay, why negative 7 sine x? Because cosine x is negative, derivative of cosine x is negative sine x, but that negative will now belong to everything. So the answer here is negative 7 sine x. Letter B, I am having a product rule again. I have x squared and sine x. Okay, so means u is x squared, v is sine x. The derivative of u is 2x. The derivative of sine x is cosine x. Okay, so product rule says v du plus u dv. Okay, thus it will be, you just plug in, it will be sine x times 2x plus x squared times cosine x. Therefore, the answer will be 2x sine x plus x squared cosine x. Okay, letter C, we will be using quotient rule. Why quotient rule? We are dividing two expressions. Okay, I have this as the first expression divided by the second expression, x. Okay, remember that the derivative of tangent x is secant squared x. So there, but basically you have to represent them with u and v. Okay, the numerator will become the u, 3 tangent x. The v will be x as the denominator. After that, get the du, which is 3 secant squared x. What is dv? It is 1. And quotient rule says v du minus u dv over v squared. Okay, so those are the things that you need to remember. Plug in, you will have this, x times 3 secant squared x minus 3 times tangent x times 1 over x squared. Okay, you will just simplify. 3 times x is 3x, so it will become 3x secant squared x minus 3 times 1 is 3, so 3 tangent x divided by x squared. Okay, now let's move on to letter D. So if you notice, letter D is an expression inside the bracket with an index outside. Okay, are you familiar with this? Basically, this kind of problem, we are using what we call chain rule. And when we are using chain rule, you have to cover up, okay, whatever is inside the bracket. After covering up what is inside the bracket, you bring that index in front. Okay, then you subtract with 1, so it will become 7. Then you try to bring that back, the one you covered up, and differentiate as a value, which is 3x, 3 sine x. Why 3 sine x? Remember that 5 doesn't have any values of x, so if you look for the derivative of 5, it will become 0. Okay, and negative 3 cosine x, you notice it's negative 3 over there. Derivative of cosine x is negative sine x. Negative sine x times negative 3 is positive 3 sine x. 3 sine x times 8 will become 24 sine x. The answer will be 24 sine x times the quantity of 5 minus 3 cosine x to the power of 7. Okay, next. How about if there's a lot, you will notice now that the angles, okay, has a constant minus 2x. Okay, constant pi over 3 minus 2x. And then I have cosine 3x. So again, there is a numerical coefficient of the angle x, which is 3. Over here also, there's a numerical coefficient of the x in the angle, which is 2. Okay, also this one, there's a numerical coefficient of x, okay, in the angle 2x. Okay, so this one has a little bit of difference. Okay, what we are going to do here is, you will notice that I have this one. Okay, 5, you will see that it's cosine. Okay, why cosine? Because the derivative of sine x is cosine x. Okay, and since the derivative of sine x is cosine x, then I'll put cosine, I'll put there. But I will need to multiply it with Okay, what is the derivative of x over 3, pi over 3 minus 2x? Remember that pi over 3 is a constant number, so it doesn't have any derivative, it will become 0. Minus 2x, negative 2x, the derivative of that is negative 2. Okay, therefore the answer here is negative 2 times 5 is negative 10 cosine the angle, which is pi over 3 minus 2x. Okay, so it means, okay, if I have, okay, sine ax plus b, whatever is that numerical coefficient will be multiplied to the original, or the derivative of the original angle. Okay, so this this part is sine ax plus b, right? Ax plus b is the angle over here. What is the numerical coefficient of x? It is a. That a will be multiplied to the derivative of the sine of the original angle. Okay, what is the derivative of sine? It is cosine of the original angle, which is ax plus b. Just like what happened here, I have 5 sine, I'll write that one, angle pi over 3 minus 2x originally. Then I will multiply that with the numerical coefficient of the x on the angle, which is negative 2 there. So negative 2 times 5 will be negative 10. Okay, let's move on to letter B. Letter B, using all these rules, okay, since cosine 3x, you will notice that this is x times cosine 3x. So therefore, I have two expressions that I am multiplying. So I will need to use product rule and represent u to become x, represent v as cosine 3x. Okay, what is the derivative of u? It's 1. What is the derivative of v? Now let's try to apply this again. Okay, it is cosine ax plus b, but there is no b over here. We only have ax. So that a, okay, which is the 3, will just be in front. 3 times cosine what? You bring back the original angle, which is 3x. Okay, it's not anymore cosine, sorry, because the derivative of cosine is negative sign. So negative 3 sine 3x. Okay, then you apply the product rule, which is v du plus u dv. Okay, next plug in, then you will come up with the answer. Cosine 3x minus 3x sine 3x. Next, I have now x squared over sine 2x plus pi over 4. Okay, so you notice that the numerical coefficient of x over here is 2. So since the numerical coefficient of x here is 2, then you have to bring that out, okay, and find the derivative of sine, which is cosine. Then plug in the original angle, which is 2x plus pi over 4. But it's not as simple as that, because this is division and we are now applying quotient rule. Okay, so let u will become the x squared. B is equal to sine the angle 2x plus pi over 4. Derivative of u is 2x. Derivative of v is the one I'm sharing a while ago. 2 will be outside. And then derivative of sine is cosine. Then plug in the original angle, which is 2x plus pi over 4. Okay. Next, of course, since it's quotient rule, it's v du minus u dv over v squared. Okay. V plug in, du plug in. So you just plug in everything, you will get this. Okay. So if you can simplify this using your algebra, then try to simplify. But I think I don't have anything to simplify over there unless I want to extract out 2x and 2x, okay, and bring it out as a common monomial factor. I can do that, but this one will be acceptable already in the IGCSE additional mathematics exam. Okay, how about letter D? Again, it's chain rule, but you notice that the angle is 2x. It's not just an x, but there's a numerical coefficient 2. Okay, so you bring that out, you multiply it with 3 to find out the derivative of the one inside the bracket later on. But of course, it's a chain rule, so you cover this one, bring the index in front, minus 1 will be power of 4. Okay, there. Find the derivative of that. There is no derivative of 1, it will become 0. Okay, tangent 2x is 2 secant squared 2x times the number over here, which is, or the numerical coefficient, which is 3. So 2 times 3 is 6. It will become 6 secant squared 2x. Okay, this 3 times 2 is 6. Okay, 6 times 5 will become 30. That's why this one becomes 30. 30 secant squared 2x times the quantity of 1 plus this 1 plus 3 tangent 2x to the power of 4. Okay, that ends my lesson. Thank you for watching this video. I hope you have learned something in finding the derivatives of trigonometric functions. Thank you and God bless.